Welcome to the technology and business sessions. To start with, I would like to invite Professor Wolfgang Ziegler, who's gonna join us online. He's the professor at Hochschule Karlsruhe University of Applied Sciences, Germany, and he's part of digital information services in technical communication based on content management and delivery semantics. Professor Wolfgang Ziegler, over to you. Is he with us?
Yes, I'm here.
Hi.
Thank you. Thank you for welcome and thank you for inviting me. So I would like to give a presentation and just share the screen now. So, yes. So I would like to present on digital information services in technical communication, which is typically a field people don't have a focus when it comes to IT and business, but it's something which is very vivid and very active, especially in the European area where I'm working. I'm working at University of Applied Sciences in Germany, and there is a faculty of information and media management. At the same time, I'm running a kind of business for consulting, so I have a lot of cooperation also with industry, which is the concept of this kind of universities in Germany. So what I would like to report here is, after a short introduction, I would like to show some data on recent study I did with the Association for Technical Communication last year. And then I would like to explain a little bit what it means, content management in the field of technical communication, and more modern concepts of content delivery and digital information services. And if there's a little time at the end, I would like to also report about some research projects where we use semantics to have, let's say, more connected, intelligent content. So just to introduce the topic. When people hear about technical communication, in many cases, they don't really know what it is. So I picked the definition of the US association, the STC, and it's about communicating about products, and which means there are always a connection to the subject matter experts, because we have to communicate to customers or to technicians about any specialized products like IT, like hardware, like automotive, like any kind of engines or something, or medical procedures, or any regulations or anything. Could be in a much more broader sense, any kind of products or services. So there are subject matter experts. So what I'm dealing more is about technology and the media. So our students have to learn about the technology, how to communicate. So not only web technologies, it's any kind of IT means, IT technologies to provide information. And the third area would be like how to communicate, like instructional design, any kind of communication, intercultural communication. So this is also something which is in our program, what students have to learn. And the main goal of technical communication is to provide information in the right way, which means just fitting the products, if it's a very high specific, high variant rich products, and also at the right time. So very quick, very easy to access the information, which is typically quite different what people experience in many cases when they just read ordinary manuals. So we want to do much better. Once you sell very complex business-to-business products, you need real specific information on how to use, how to service, because they're very cost-intensive. So it's also a very important thing to deliver the right information. So this is what we do dealing with our students learn, and also what the business professionals have to do. Just a short look at our program, what we do at our university. So we don't have to go in detail, but students have to learn about language and communication, as I said. So it's like one of the pillars. Others are media and information management, which is more the IT side. I'm working there on this side. So of course, all kind of database technology, information management, multimedia, AI, VR, anything which is relevant there for communicating information. And then also like design issues and also classical documentation. So this is just a brief look into our program. So looking at industry, I think there's so many bad examples of information which is out there, people have to understand. And this is just a brief screenshot of something of one of my customers who want to do better, because it's a mix of different, let's say, variants and parameters. And the customers and the users have to read through, have to find the right information, have to think of what kind of diameter is my product, what kind of variant is it, what kind of coating material do we have, in order to retrieve the right information. And this is not the future of content delivery, of information delivery. It should be more easy to retrieve the information. And this is what all companies, all scientists are working on, how to do better. So what companies want to do is, they of course want to improve customer satisfaction. They want to improve user experience, want to improve customer binding. But this just means they have to reduce complexity for the people who are looking for information. So the level of complexity has to go away from the external side. It should be less complex for the outside world, for the users, for technicians. But this also means you cannot just delete complexity because it's in your products. So this means there must be methodologies how to handle complexity in the insight management of the information. And this is what we're doing, how to handle complexity to make it easier for the end users to retrieve the appropriate information. And this, of course, has to be integrated, for example, in IoT process or into software development. So in the whole product lifecycle. And we want to use, of course, the recent electronic media, any kind of apps. So what people are expecting, there must be a better information exchange of structured information. And of course, there will be new product services based on information. So this is what people wish to do. So in the last 20 years, there was like a development of certain systems in technical communication. And I will explain a little later what they look like and what they do. They are called content management, but especially for technical communication. So it's like component content management. So it's called CCMS, which were just a tool for making it more efficient to create manuals. But nowadays, it's much more elaborated, it's much more broad. The outside perspective has been taken into account, which means now we have content delivery, which are more or less like search portals with very intelligent search mechanism in order to deliver more granular information. So this is what's content delivery about. But the main goal is to offer better information services. So this is the reason I call this talk also like digital information service. So something which really serves, with which you help the customers and the end users information, which also could be like a business model, what also a lot of companies now do, to let the customer pay also for information. So there's a kind of involvement of the field of information management attached to technical communication. And I will show a little bit later how it really looks like. All right, so now let's look on a study I did with the Association of Technical Communication in Germany. They are addressing the Central European market. And so we were asking, so what are companies are doing in terms of digitalization? So what kind of initiatives do they have running at the moment? And it's initiatives which are combined with content to any extent. And what you see here as the high runners. So they want to integrate content sources from different departments and build up any kind of application. So content providing software They also have projects with knowledge management, and we will come to this, what it means, knowledge management. And they have these content delivery portals, which just take the granular information from this component content management system and display it in a better way. You can think of it like online help, but much more intelligent, much more granular, much more supportive. And there are many more initiatives out there on the market. They do like digital archiving, exchange platforms, better service management platforms. And you can see there are initiatives which are dedicated to the end user, to the customer, and there are internal ones, which just means a better organization of their information structure and their information logistics. And we were interested, what were the drivers, what were the goals of these initiatives? And for the external ones, it's what I said before, it's enhancing, it's increasing customer satisfaction, increasing usability, having better customer loyalty, which is customer binding, have better media involved in the process. So anything which makes customer and users more happy, more satisfied. And there are, of course, a lot of initiatives which want to create new business models, who want to earn money with content, but this is the second step. First, they know they should do better, and we will report how they want to do better in the second and third part of this presentation. In terms of the internal initiatives, it's like the old problem, it's not easy to find information in-house in their company. So people have a lot of initiatives to have a better information exchange inside the company, to enhance productivity of product development, of sales, have a better quality assurance, improve communication within departments. So there's a lot of things going on this side. So just to prove that this kind of CCMS, this specialized content management system for creating granular content, is a very long time on the market. So the systems out there, like more than 15 years, more than from 11 to 15 years. So just roughly speaking, like 70, 80 or 90%, depending on the country, and in Central Europe, have this kind of systems on place. So they use it heavily for creating structured information in a very efficient way. So only like 30% in this study, they don't yet have it. But it's like huge companies in machinery industry, they all have this kind of system. If you look at CDP, content delivery portals, this kind of search portals for granular content, it's also like 2/3 of the companies have it in place. So the blue ones here, they're just evaluating, having proof of concepts, they're planning these. So it's something which is just there on the fingertips of people, and they will start it within the next month or year. And there are other ones who already have it in place, they use it, they optimize or even have a transition to other content delivery portals, and they're already experienced. So 1/3 at the moment don't have it. We looked also on semantic technology, which is like knowledge graphs and ontology modeling, any kind of knowledge modeling. This is in the background. It's not so often at the moment. It's like maybe 40% of companies, if you look at the total market, and it's used for knowledge modeling, for supporting product selection in terms of variance, in terms of combination, like configuration management. So it's there, but it's used at the moment not so often for content application. And I will show at the end of the talk how we use it, knowledge graphs for content delivery. And with just shortly before the upcoming of ChatGPT, so the usage of AI was heavily in translation management. So a lot of translations, of course, they use machine translation, which is AI-based. And there are some initiatives in automatic classification of content, but there will be a huge increase of this in the upcoming years, also maybe for text generation. but at the moment it's still it's starting. So having this in mind, I would like to explain what these systems do, the content or component content management system. So I have to explain a little bit about content management and delivery, and also how these information services could look like. So in a very simple picture, how manuals, for example, are created at the moment. In most cases, they are split up into topics, into, let's say, like a half-page or one-page information chunk. They are written in a structured way using XML as a data format. They're stored in database as reusable topics, and they are assembled to certain degrees in an automized way into document structures. So this can be done manually, but this can also be done by automated processes. So if you have parts list-based document generation, this is something you could do, or other configuration-based document assembly. This is something which was the development over the last 20 years. And people use it heavily, as I said, at least on the European market, where I'm mostly active. So there's some standard systems out there, like 20 different systems, as the CCUS, which are used for creating topic-based content. So this is maybe the important message at this point. People create topic-based content, and they can deliver all kind of output media. Could be like printed material, could be any kind of PDF or something for mobile devices, or put this content delivery portal as searchable topics. So this is a standard toolset at the moment. So they support variant management, they support, of course, versioning management, which is the change management in the life cycle of products. They provide interfaces to translation management, and they create all kind of output media. So the goal is to have a controlled reuse and repurposing of content topics or content chunks, wherever you would like to need them. So the secret behind the topic is not only that it's a content chunk, but it's associated to a set of metadata. And there are certain methodologies how this metadata can be assigned. One of the pretty common and often used is something I called it's the PI or PI classification, which just means you figure out the component which is described inside a topic. Could be also a software component or a software function, so in a virtual way. So you describe information class or what's contained, and it must be really like a very specific selection. So when in this topic there's a repair information, it's nothing about the functional description or the disposal. It must be really dedicated to this information. It must be a clear definition, and writers must stick to this definition and just include the right information for certain information classes. And then they would say also what kind of products this topic can be used. There will be a range of products like software versions, or when you go to automotive, what kind of car types this topic can be used. And you can even include what kind of specific variant properties, whether coating, what kind of coating, what kind of diameter. So exactly the problem I showed before of this unstructured information should be handled in terms of metadata and in terms of validity of certain content chunks. And there could be also more metadata just describing the connection to IoT processes, under which error codes, for example, certain topics should be displayed, and for what kind of target groups it can be used. So it's really a multidimensional information space, and writers, they don't only write content, no, they associate classification with and to the information topic. So this is like a real life example where it is an excavator in mining environment and someone who just writes information, and it's not necessary to read here. He just sees XML content, and the writers have to select the information classes and select the components they're described in order to really create selectable content. So this is also support for content engineers. They work with the taxonomy of classification. So, and now coming to the delivery, which is, even though it's in German, but I think we're all used to web shops and product portals, I would say, and using faceted search and categories. And this is just now the same with the content. Now we can just offer this kind of search portals also to the user information. And I just picked an example which fits to the content creation before. So people have faceted search. They can say, I want to see an instruction for the windshield washer or the fluid for a certain excavator. And there's the topic. They don't have to browse through documents anymore. So just this topic will be displayed, and you can just click on and say, okay, that's information I really need. So this is the idea of faceted search using the metadata which has been assigned to the content. So there's faceted search. Of course, still you can use text search with full text search, and you still can use document navigation as long as you want to deliver a document in it. But the topic is the leading part of it. And you can also mix these ways of accessing content. So this is a content delivery portal, one example of it. So now coming to this study I've shown before. In such an environment now in companies, they don't only have technical communication, they have sales departments, they have engineering, they have service departments, and they all can deliver information which might be helpful at the end for the user, for the technicians. So this is the reason why so many companies are dealing with application from different departments, because they want to build up apps, they want to build up support portals. And so they need content from different areas. And so far, I was only talking about content from the TC department, from technical communication. Their dedicated help environment would be the content delivery portal. So again, here, it's number 3. So they're very active on it, but more activities are in this mixed content application. And there will be something between, I will explain in some minutes, about the knowledge management. It also has a role here as an important meaning. And this means the topic-based content has to be provided into these applications now by web services, which usually is called a headless content delivery portal. So in this mixed environment, there will be requests by metadata, and the headless CDP would deliver as a content service the topics to this application here. So this is now a very active field to build these combined applications. And now how to build an information service. So I have an example here of a company in Germany, maybe you know the Beirat company. They offer seeds and crops and fertilizer. And so what they do, they enhance their business. They do digital services, how to help the farmers to get better results on the fields by sensing, for example, how many bugs are in the fields, or how much fertilizer they need, how many seeds they should put there. They have drones for the surveillance of the fields. They have satellite technology. So they build up a digital story around the traditional products. So not anymore seeds and fertilizer and crops and pesticides, but have digital services. You find it on the web, what they do, and how they support the farmers. So this means this is a digital service, and the content is part of it. So I don't have here technical communication example, but I think it's easy to imagine also how to integrate content in terms of using the tractor or the harvester or anything. So this is now a digital story. And now there are many examples of other products. This is an air conditioning by the Daikin company here, which has apps to support the installer of air conditioning. So it's something, it's called an e-doctor, and you can find it on YouTube. There are nice examples of it. So you scan your air conditioning device and you get information, for example, about troubleshooting, about component check, about component repair. So this information here just comes directly out of the component content management system. So this is a product of the technical communication, but it's built into an app as a digital information service, supporting the installers and have a better customer binding. So this is also a nice example, and again, I recommend if you go to YouTube, there are really impressive examples how this plays together. And then others in machinery industry, like here Caterpillar, they have now like an augmented reality applications for servicing these wheel loaders here. So there are many examples, if you look at it, how to include the content. This here comes from the component content management system, and it's a service app. How to support, again, service technicians when they have to change, for example, the air filter or replace it. This is an example of a German company who sells water plants, and beside the water plant, they also offer the information services for augmented reality application, for controlling, for checking, for repair these devices here, and also include the documents. So if you want to include it in a very efficient way, this shouldn't be documents, this should be topic-based content in order to get the right information at the right place, which was my introductory remark. And as a last example, this is a company also in Eastern Germany von Ardennes called. They have high technology coating in semiconductor industry machines, and they sell their e-learning, which is component based. So just behind this environment, there are electrical equipment, there is the cooling water and sensoring technology. They have just dedicated e-learnings like modules, which are again associated to these components here, and they sell it as as a business case. All right, so if this is something which is not only accepted, but which is required on the market, not only to have high quality products, but also to deliver high quality content and information services. I would like to show how now semantics comes into the game. I just like to look at it as like a cascade of intelligence levels. So what I explained so far in terms of the metadata is just what I call native intelligence. So people have to put by hand metadata on their content chunks, on their videos, on their e-learning modules. So it's really manually work, and it's important that people know what to do. But there's a second level, which is the augmented intelligence, which is just using semantics, knowledge graph, knowledge technology. And of course, there's the upper level artificial intelligence, but I will not talk today about this. I would like to look at the augmented intelligence now. So why is in technical communication so important also to include knowledge graphs? And the reason is pretty easy, because they are dependencies. They are relationships between metadata. There are certain components which are only available in certain markets, or only in combination with each other, or only with a certain product type. So there's so many dependencies. And in many cases, the writers are a little lost in metadata because they don't know about the right combinations, what to select. And this is the natural field of ontology, of knowledge graphs. So how to model this kind of dependencies. And in the picture I've shown before, it's also natural to think now of a like integrated scenario and data governance. Actually, in detail, it's metadata governance. So I said before, there are many information services which need content from different sources and from different areas, which just means there are also different metadata schemes. So there must be an overview. There must be an understanding of the different metadata schemes. What I had here in the CCMS, like taxonomies, it will be different here. And you need here like a layer to make it possible to understand how they are connected, the information of the different sources. And this is the natural field of ontologies, of semantics. So this is now the reason why the companies are so much interested also in knowledge management. They have a common understanding of the different areas of the content, and also like the departments, what kind of content they provide and they deliver. So now it's easy to understand why they are just the high runners of our study. So there are many applications on the market where they have ontologies, which also looks like this nice networks. And this is an example of a customer of mine, which tries to model, and sorry, it's in German here, but I just explain very briefly. They model what kind of competencies they have, their products have, what kind of processed media. They sell valves for fluid technology. And the reason why they do this, they want to support sales departments. So salespersons, they supported once they selected the media the customer has, what kind of functionality should be supported, they automatically detect the information which is needed inside the sales process. So I cannot show the system here, but I can show a little bit in the background how the model was made. So it's ontology for sales processes. Coming back a little closer to the field of technical communication, we use ontologies, as I explained, to support the content creation process, to help writers to have the right metadata and to pick the right combinations. Ontologies are used inside of content delivery, which means inside the search portals, as I've shown it, to show the relationships between content and to model it. And I have some tiny example of this in the last part. And if you have larger companies, they have this ontology, as I said, as like a semantic middleware, like an information hub, which connects the different departments and tries to help people understand the connection between information of these departments. And of course, CMS and CDP can also benefit from this. So this is a larger project, which are not usually done by mid-sized companies, but going back to this, this kind of delivery support, this is now done quite often. Yeah, so this leads to the last part, and I would like to speed up a little bit because there's some research I do with my students, with my grad students, together with companies. So it's real industry, academic cooperation. And let me skip this. Let's go here. And it's once you deliver on your content in a topic-based manner, there's still some need, some requirement to have some, let's say, a structured set of topics which have a relevant context, which belong to each other, which describe a use case for any kind of repair or something. So it would be, in many cases, quite be helpful to have some, well, let's call it rules, what kind of topics should be displayed together. And this was the starting point of doing something like correlation rules, as I called it 2 years before. So it's like a primary object, you look at it like on a topic, and you can derive some rules, what kind of secondary objects should be displayed based on metadata. So this is the important thing. We now use the metadata from CCMS, which are at the end included in the ontology. So it's an ontology of metadata. And you can build up pretty easy rules how to connect these topics. You say there is a topic for the connection and the getting started. Then there should be a second topic displayed for the manual diagnostic of this product or the contact data or something. So it's no linking by manual, means. So no writers do the linking, but it's linking just from metadata to metadata. So this is would be in a graph environment. So there would be a rule that whenever there's a connection and putting to use. So there should be some other objects which have metadata, like displaying the operating element, default analysis, and it should be displayed at the same time. So what we do, we use different modeling tools because it's independent of any modeling tool. You can use Protégé as an open source software, but you can use any of the commercial tools because it's just a methodology you put on top your existing ontology. And once again, the ontology includes the metadata of the CCMS. So this is maybe the secret why it's so easy to use. So what we do, we now build up this ontology, including the metadata. We model the rules between content. We set up some REST services. We did this together with my students, some APIs here, describing the connection between metadata, and just helped the content delivery portals to interconnect the content. And the nice thing is, this can be done across different systems. And this is what we did for a company, a German company, which is the Leaper company. So they have, for example, they wanted to connect a spare parts catalog and they want to use a content delivery portal. I just show the results here. So this was the content delivery portal, and it's the same I've shown you before. Someone is looking for a maintenance task for cleaning the air cleaner. So this would be the delivery portal. And once he clicks on it, the tool just sends a request to the graph database, and there will be some linking, automated linking between different systems. So this would be into the parts catalog, and this would be inside the delivery portal. And down here you see a little bit, it also works on the other side or the other way around. So this is a spare parts catalog where somebody looks for any kind of like a filter or what is near air conditioning, and at the same time it queries the graph and gets the information where to go once they need content from the content delivery portal. So it's a linking between different systems, which can be done for any system which can do a web call. So we have a lot of projects right now with companies who want to do this, like a trial. They put in a lot of work into CCMS, which means this topic-based content. They put a lot of work into the metadata, and what we show them is how to take a benefit from this in terms of automatic linking according to certain use cases. And the use cases are gathered, for example, from service technicians, which have a lot of experience and say it's good to display not only this topic, but also give them a hint what other information should be browsed or should be read. So this now comes to the end. So we have a lot of these industry academic projects right now, and even companies now implemented in their real life environments. So it's a natural extension of what I explained, what we do in technical communication for a long time. So CCMS and granular content. It was a nice project for students to have these creating these correlation rule API. It's a good means also for the companies, because it's like a test of the quality of the metadata. And companies learned a lot how also to improve the metadata. It's a way for expressing hidden knowledge to gather from the service technicians. It helps companies to start with semantic technologies. But it needs also some educated people, which could come from data science, or we call it, should work as information architects. And it also can be extended also by AI technologies right now, because these rules could also be analyzed and like detected from the user behavior, from analytics in the web portals, which would then be a nice combination of manual models and AI detected rules, which could be put in this correlation rules. And I think that's it for the moment. Thank you very much for your attention.
Thank you, Professor Wolfgang Ziegler, for that very informative session.